Hey, neuroscience friends. I am super bummed that we're not getting to see each other this year, and I know that not everyone is doing the virtual meeting, so I thought I'd share my SfN poster with you this way. There's a link to a preprint in the description below if you want to know more about the study, and of course I'd be happy to take your questions through email or through Twitter. If you are going to the virtual meeting, my poster is going to be on Wednesday at 4:30 Eastern, 3:30 Central. I hope you come by. I'd love to chat. Otherwise, I guess I'll see you all next year. Until then, take care.
Hi, I'm Vince McGinty, and here's my SfN poster in a nutshell. A quick shout out to Shira, my graduate student, who collected a lot of the data that you're going to see here. We have a preprint on bioRxiv, and of course, I hope you come by the virtual session on Wednesday, 4:30 Eastern. Also, my lab is looking for both postdocs and grad students, so if you like what you see here, if it looks like a good fit for you or someone in your lab, please get in touch. I'd love to chat. All right, in this study, we're interested in the role of the primate orbitofrontal cortex, or OFC, in value-based choices. And we're specifically interested in those instances where we have to make a choice between two things that are near or equal in value. Because in those instances, decisions are often variable from one trial to the next. And so the main question that we're asking in this study is, when decisions are variable, can we explain that decision variability in terms of underlying neural variability, specifically variability in the activity of neurons in the OFC? And this is an important question because if we can link neural activity and behavior in single trials, it means we can begin to understand how that neural activity, how that value information is read out or transformed downstream, and how it ultimately influences behavior. So really what the study is about is trying to get at sort of the fine-grained nuts and bolts of how the OFC actually contributes to value-based choices. So we had monkeys perform a two-alternative forced choice task where in every trial they chose between two different offers of different amounts of juice reward, ranging in value from 1 to 5 drops of juice. The offers were presented to the monkey sequentially, so in every trial they saw one offer and then the second offer. And we can see that when the offers were very different amounts of juice, the monkey almost always chose the larger of the two amounts, and that's indicated here by the extremes on this choice preference curve. However, when the offers were equal in value or near in value, the monkey's behavior, the monkey's choices, were much more variable. Sometimes he chose left and sometimes he chose right. Now, during task performance, we recorded from neurons in the orbitofrontal cortex, and we used multi-channel linear arrays. And what this allowed us to do is record not just from one neuron at a time, but from many OFC neurons simultaneously. And on average, we recorded about 45 neurons in a given session. And that's going to be important in a moment. Now, like many other studies of the OFC, we found neurons that represented the value of the offers, meaning simply that they scaled their firing up or down according to the magnitude of the juice reward that was being offered. And you can see an example of one such neuron here. The question that we had, the thing that we were trying to answer, is to try to link the activity of these value coding neurons to the monkey's choices on a trial-to-trial basis. Now, instead of trying to do that one at a time individually for each of the neurons we recorded, we decided to take advantage of the fact that we recorded from many neurons simultaneously. So what we did here was try to link the population level activity that we recorded in every session to the monkey's choices. Now, this is an overview of the analysis that we used to do that. I'm not going to go into the details here. You can check out the preprint if you're really interested. Basically, what we did in every trial is we computed what I call an ensemble value code. And what that is basically a weighted sum of the value signals from all of the neurons that we record in that session. And we treat these weighted sums as single trial estimates of the subjective value of the two choice offers on that trial. And then we use these estimates as inputs into an ROC-based binary classifier. What we basically do here is we ask if we can predict the monkey's choices on a trial-by-trial basis based upon these neurally derived estimates of the value of the offers, based upon these ensemble value codes. Now here is a summary of the results. On the x-axis is time. This is time since the two offers are presented to the monkey. And on the y-axis is how accurate our predictions are. 0.5 is chance, and anything above or below that indicates better than chance performance. And what we can see is that as soon as the choice options are shown to the monkey, we can begin to significantly predict his choices at better than chance levels. And we can do this using either our neurally derived estimate of the value of the first offer, which is shown here in black, or our neurally derived estimate of the value of the second offer, and that's shown here in blue. Now, what I don't have time to show you is the fact that these two estimates here, these two ensemble value codes for the first offer and the second offer, are independent from one another. And what that means is that we can obtain even more accurate predictions if we combine both of these signals in the same classifier. Another important point here is that the predictions that we get based upon these ensemble signals, which are shown here in the solid lines, are far more accurate than the predictions that we get if we simply do this analysis on single cells one at a time and then average those predictions together. And what that tells us is that in order to access, the meaningful neural variability that's ultimately linked to choice in this task, we need to measure those value signals at the ensemble level. We can't do it simply by measuring one neuron at a time and averaging those predictions together. Now, there's a lot more in this study. I hope you come check it out at the virtual session, again, Wednesday at 4:30, or if not that, check out the preprint. I'll just wrap up for now by saying that we showed that we could predict the monkey's decision intent. We could predict decision outcomes based upon ensemble level value signals that we recorded in the orbitofrontal cortex, and that these ensemble level signals gave us much, much better predictions than what we could get from single neurons alone. And what this points to, I think, is a very clear and straightforward conclusion. It gives us a very parsimonious mechanism for how OFC could be contributing to choice, which is by providing simply a linear readout from independent ensembles of neurons encoding the two offer values. Now, this is by no means a new idea, but what's significant here is that it's the first time that we've been able to obtain direct evidence for this very simple mechanism, to directly link value representations in single trials to the outcome of individual choices. And we're very, very excited about this. We think this really points the way to the future of how to study neural mechanisms of value-based choice, which is, first of all, to focus on variability in decision outcomes, and to try to explain this variability in terms of ensemble level representations of value. All right, thanks so much for coming to check out the poster, and I hope to see you on Wednesday. Bye-bye.